Hello, how are you? Can you hear me? Can you hear me? Hello. Hello.
Good morning.
How are you? Good morning. How are you today?
Good. How are you?
Fine, thank you. Guys, give me a few minutes. Let me take down the attendance. Said that Lee went down. Like,
Hello, sir.
hey, how are you?
I emailed you around yesterday 2 days ago. And I just wanted to know, did you see the email?
What's her name?
Marvelous.
Give me a minute. Let me finish with the attendance, then I will check it. I'm
Okay.
gonna answer all the emails. I got some emails, but I'm gonna answer all of them today.
Okay, thank you.
But I'm gonna. It says marvelous.
Yeah.
So let me finish the attendance, then I will check it. See if your name is there. Yeah. That again. Johnson. Oops, I got Forbes. Okay. Got it. Again. It's Johnson. Let's see it. Marvelous. Okay. I'm here. 1, 2, 3, 4, 5, 6, 7. Owen. All right. So yeah, I got some emails, and I'm going to just like I'm behind on my emails and grading too. But the good news is that this is this Thanksgiving holiday. I will use it to do a lot of responses and grading. Okay, so no worries. Okay. Yeah, Cruas, Chamani. All right, let's begin. Today I know that some of you might be traveling, so I decided to have this at home. I mean, remotely, so that you can have time to prepare for your trips. I introduced you to hypothesis testing last week. So today we actually do the main testing of hypothesis. There are two major ways, actually three, but we'll focus on two ways. We have z-test for the mean, the traditional method, z-test for the mean, the p-value method. Now we can also have z-test for proportion as well. Then the third method is we want to do the z-test for the mean, but you'll be using the confidence interval approach. So let's look at the first one. that's what we'll be focusing today. Z-test for the mean. You can see the working rules here. You state the hypothesis. This is the traditional method. You state the hypothesis and identify the claim. You find their critical values from the table. The table I will use in the class, and I told you to print and to keep handy. Then you compute the test value, make decisions to reject or not reject null hypothesis, then summarize your results. So this is what we do in hypothesis testing. Now, how do we reject or not reject? The criteria for rejecting or not rejecting the null hypothesis under this method is as follows. You reject the null hypothesis if the calculated value is equal to or exceeds the critical value. Excuse me. So, excuse me. So that means if your answer is larger than the critical value, you reject the null hypothesis. On the other hand, if your answer is smaller than the critical value, you don't reject null hypothesis. Okay? So the test statistics is as follows. Z, because this is a Z-test, equals X bar, which is the sample mean, minus mu, the population mean, divided by the standard deviation over the square root of n, where n is the sample size, and this is the standard deviation. So now let us try this for this test here. It says that a researcher wants to report that the average annual salary of assistant professors in 1997 is more than $42,000 a year. A sample of 30 assistant professors have an annual salary of $43,000. And at alpha equals 0.05, test the claim that the assistant professors earned more than $42,000 a year in 1997. This is just what they're testing. So I want to show you that that's the key for you for stating hypothesis. Remember, I showed you how to take state hypothesis last week, and then this is a part of it right here. Now, say earn more than $42,000 a year. So the first thing to do is to state your null and alternative hypothesis. So I'm gonna make this a little bit bigger. Okay. Your null hypothesis can be your null alternative are stated as follows. HO and H1. HO, okay, and H1, like we did last week. That's the first thing you do where you are testing hypothesis is to state hypothesis. If you're testing, somebody's keep coming and okay, HO and H1. HO, I'll make it this thing bigger. So using this part of the okay, HO and H1, because it says n more use greater than symbol, and you can only use greater than symbol in the alternative hypothesis. So we're gonna use mean equal to $42,000 this is the claim. And no, not equal. Let me see. It say n more. Sorry, n more gonna be greater than 42,000. Because you can use greater than in the only in the null greater than or less than, we can use it only in the alternative. Now the null hypothesis states the opposite of that. Null hypothesis will be mean, the opposite will be less than, but we cannot use less than symbol in the null hypothesis. You can only use less than or equal to. And that's what we're gonna use, less than or equal to, which is right here, 42,000. Okay, that's the first step in testing hypothesis, to state the hypothesis and identify a claim. Now, somebody might say here that a sample of 30 professors has a average salary of 43,260, which is bigger than 42,000. Then the person might be asking, why are we testing if we see that this average is already bigger? Well, remember, the average is only for a sample of 30 professors. So it might be bigger just in that 30 professors, but how about the entire population of assistant professors? So that's why we still need to test the hypothesis. Now, once you state the hypothesis and identify your claim, the next thing to do is to find the critical value. Okay, find the critical value. So the critical value, it says to use alpha 0.05. You can see already alpha 0.05. So we got alpha equals 0.05. Adjust this, alpha 0.05. And because it is saying greater than, you have greater than symbol in the claim, that means that this is a right-tailed test. So you have it in this form. The chart will look like this. It's gonna look like this. Okay. This chart is gonna look like this one here. You have okay. I can draw it at the side. No, let me draw it here. The chart will look like this. But before we can draw the chart, we need to get the critical value first. So now, because this is a right tail, we cannot get the critical value by using the method we use for confidence interval, because confidence interval have two sides. So this one have only right tail, one side, right tail. So we're gonna do the critical value Z alpha. We're not gonna do alpha over 2 because it is not two-tailed test. But just use alpha. Okay, critical value, critical value Z alpha equals now remember, this is a tail, right tail test. So let me draw the chart now. So it's gonna be like this. Critical value will be somewhere here. I will have 0, and the critical value is Z alpha. Z alpha. I'm gonna put alpha here. It's the right tail. Then I can now draw my chart here. Then put the bell curve. Okay. Right. I'll bring this closer a little bit. Now I'm gonna adjust this. Put the center line. Then make some adjustments in here. We're gonna put the line that's where you have the critical value. Here, gonna be right here because it's a right tail test. It's a right tail. Then I'm gonna share this. Okay, share this right there. I'm gonna put right here. So now once we finish sharing, we can go and get the critical value from the table and put it right there. Okay. Yeah, this is gonna be here, a little bit here. Okay, so now one more. We need one more of that. Just all the text. So you can see this is right there. So I'm gonna go down so that we can put the adjust the Z alpha to be here. So where you have the critical value equal. So now since on the tail, remember when we are doing normal distribution, only for at the tail you subtract from 0.5. So you're gonna do 0.5 minus because I have only one tail. So they give you the alpha as 0.05. 2.05. Okay. That'll give you let's go and look at this here from the table of normal distribution. So we have 0.5 minus 0.05. So 0.5 minus 0.05. Okay, give us 0.45. We got 0.45. So have 0.45. Let's see. Let me share this. Yeah, 0.45. We have it. Looking for our workbook. Okay, I've seen it. Okay. I'll make it like okay. Try it again. 0.45. Know what our table is. 1 minute. I'm trying to share the last page again, but it's not showing, but I'll get it. No worries. Maybe I open too many sides. Okay, I'm gonna close some spaces. Just give me 1 minute, but close here. I see it now. Okay, good. So we'll go here and say, okay, 0.5 minus 0.05. So we get our answer gave us as 0.45. So we go back and say 0.45. 0.45. You know, there are always 3 digits. That gives us the critical value of the answer we'll get here. The critical value we'll find on the table. We go and look for the value that corresponds to 0.45. So let's go and look for that value on the table of normal distribution. This is 0.45. You look inside the table. Let me make the table a little bit bigger. Okay, good. Now we look for 0.4500. 45. You have 2 of them, 0.4495 and 0.4505. These are the closest. So the values that are closest to 0.4500. See, 4500. Have 2 of them, 0.4505, 0.4505, 45 and 0.4495. Each of them are 5 points away. So when you have it in that form, choose the bigger one, and then you follow it to the left. To the left, you will see 1.6 here. If you go up 5, so we got 1.65. So that will be our critical value, 1.65. 1.65. So that's what we're gonna put here for critical value. I'm gonna follow it down. 1.65. So if your answer is bigger than this, you reject hypothesis. If the answer is less than this, you don't reject. Because if your answer is bigger than this, that means it falls in the rejection region. This is the rejection region right here. But this is the acceptance region. If you fall below this number, because this line here represents 1.65. So if you fall below this line, or if it's lower than that line, you don't reject. So again, you state hypothesis, identify your claim, find a critical value, draw your chart, then let us run the test. To run the test, we need to get our values. We need our mean, population mean of the population mean is according to the question we have. It says that the average annual salary of assistant professors in 1997 is more than 42,000. So population mean is 42,000. Yeah, $42,000. And sample mean, he said that they get a sample of 30 assistant professors. So N is 30. N equals 30. And for this sample of 30 assistant professors, this sample mean is 43,260. Let me write it down. 43,260. So the sample mean is 43,260. Okay. Okay, right here. So to get the sample mean, I cannot get the character that shows with the X bar in this workbook. So I'm going to get it from the other workbook. So I will be taking you to the other workbook to get that character for sample mean. For that character, we're going to use the correct character for it, which is X bar. So I'm going to put the symbol from here. Got X bar. So I'm going to make it bigger. Make it bigger, much bigger. X bar, see I got the character now. As you can see, X bar is, it's a 43,000 equals 43,000. Oh, excuse me. Equals 43,260. I'm going to copy this. And then paste it right here. See? And the so then this is the standard deviation. The standard deviation of the the standard deviation of the population is 5,000. See, 5,230. So the standard deviation will be 5,230. So I'm gonna go there and put it. I'll go down and put the standard deviation. Okay. Standard deviation will be delta equals 5,230. Okay. Now adjust this. Okay, because 5,230. Now we have all the values we need now. Now let us run the test. Again, to refresh your memory, first thing is to state the hypothesis and identify a claim, get your alpha out, find the critical value, Z alpha, since it is a right tail test. So we're not going to use alpha over 2. If it is 2 tail test, we write Z alpha over 2. It's 1 tail, so it's just Z alpha. Then you make your chart, put your critical value in the right position, since you get it from the table of normal distribution. Then write out the values you are given, the summary statistics. Then you run the test. Let's run the test now. Let me write this down first of all. I got delta 5,230. Mu is 42,000, and the standard the sample size is 30. So to run the test, we need this. We're going to use this formula here. Z equals X bar minus mean divided by the standard deviation of over root n. So let's do it now. We have X bar minus mean. We got I'm going to take you to that workbook where it will allow us to put the formulas in. So I'm looking for it now. It's right here. So that the Z, that's what they call it, the Z test. We have X bar, that X bar, okay, minus the mean, population mean, which we can get from here, right here, divided by the standard deviation over root n, standard deviation of delta, which is going to be somewhere here, over the square root of n. Okay, equals, got this, X bar, which is sample mean, is 43,000, okay, 260. And as the population mean is 42,000, standard deviation of we have 5,000. We're gonna put it the division symbol there. 5,230 over the square root of n, and our n is sample size, which is 30. So I'm going to write this down, and then we look for it in the calculator. We got Z equals 43,260 minus 42,000 divided by standard deviation of 5,230 over the square root of 30. So let's put this in the calculator, and then we can get the results. So we go to our calculator. We have clear this. We're gonna have at the top, we're gonna have 43,260 minus 42,000, okay, divided by standard deviation of 5230 over the square root of n, the square root of n and of n divided by square root of n, square root of n is 30, right? 30 is n. Okay, so you can see everything on the screen here. We get 1.32. Well, after you round it, it's gonna be 1.32. 1.32 rounded. So go there and put 1.32. 1.32. Okay, so I copy this and then paste it in our main workbook. Okay, put our main workbook and paste it there. Oh, excuse me. Our main workbook is right here. You put it right here. Paste it right down there. Yeah, paste it. See? Now it's time for making decision. Now remember, I told you the first thing, all we are doing is to make a decision based on the information we are given. Remember, the information was that the average annual salary of assistant professors in 1997 is more than 42,000. So we collected a sample to test this claim that they earn more than 42,000. So we stated our hypothesis. We got our critical values. We drew our chart. We have our summary statistics. Then we ran the test. The result of our test is 1.32. Now let's make a decision. We have that our critical value critical value Z alpha equals what we got for our critical value is 1.65. Right, 1.65. Okay, calculated value, that means our answer. Calculated value, which is our alpha, Z, which are Z, just our answer, just a Z, that our answer is, we got 1.32. See? So to make our final decision, we make it based on these two values. Okay. Now remember I told you when I was introducing it that the decision criteria is this: reject the null hypothesis if and only if the calculated value is equal to or greater than critical value. Otherwise, you don't reject it. So following that criteria, we can compare the two of them here. So 1.65 is the critical value, but our answer is 1.32, which is less than the critical value. That means if we put it here, you're gonna be our critical value start from here, which is 1.65. So 1.32 should be somewhere, gonna be somewhere here, might be somewhere on this spot, which does not fall in the rejection. It doesn't fall in the rejection region. Remember, I believe I mentioned it already. Let me say that our let's go that place. Okay, that our rejection, oh, excuse me, rejection, okay, rejection region is gonna be somewhere here. It is here, not somewhere here. It's right here. Oh, excuse me, a mistake. I gotta adjust this. Rejection region is right here. This region where we reject. Anything that falls in this region, we reject it. But then acceptance, okay? Acceptance. Excuse me, acceptance region okay, acceptance acceptance region is gonna be on this region, all this unshaded place, acceptance region. And our answer fell here, yeah, not in the rejection region. So now, a simple way of saying it is this, that the calculated value, that means your answer is less than the critical value. So you put it this way. Since reject, you say do not reject the null hypothesis. Because the calculated value, which is the calculated value Z, which is 1.32, is less than, oh, excuse me, is less than the critical value. Which is 1 of 1.65. Now, if you want to, this is just to show you why. Now, to explain it, write it, do not reject. Reject HO since 1.32 that we got, 1.32 is less than the critical value of 1.65. See? So that's the decision. Do not reject. Now, our null hypothesis is that they make less than 42,000. But our claim was that they make more. Remember, I said that to take the claim that assistant professors earn more, right? So he said, do not reject this one, which means that this claim is not correct. If we have rejected this one, which is the null hypothesis, that means that the claim is right. But he said, do not reject H1, which means the claim, that means we are taking this another. So our conclusion will be conclusion. Okay. There is insufficient evidence. There is insufficient evidence to support the claim that, and what is the claim? The claim was that assistant professors earn more than $42,000 a year in 1997. The assistant professors earn more than 42,000 in 1997. Okay. It's a conclusion. Okay. That's our conclusion. Okay. Now I'm gonna go over it one more time so that you can see what we did and perhaps ask some questions. So the question is that a researcher report that the average annual salary of assistant professors in the year 1997 is more than 42,000. To test this claim, a sample of 30 assistant professors were used, and their mean salary was, which the sample mean is 43,260. At alpha means the significance level of 0.05, test the claim that assistant professors earn more than 42,000 a year in 1997. The standard deviation of the population is 5,230. So the first thing is to state the hypothesis, which is that they make more than that. See the claim. You state the hypothesis, identify the claim, get your alpha, find the critical value from this table of normal distribution. You sure I've seen all this. Okay, good. Then draw your chart. See, this is the chart, how the chart looks like here. I'm gonna remove this. See how it looks like. So this is the acceptance, the whole of this unshaded place is the acceptance region, but the shaded one is the critical region. So anything that falls in the critical region, you reject the null hypothesis. Get your summary statistics, put them in the formula to run the test. Your answer is 1.32. Then you make a decision by comparing your answer to the critical value. If your answer is bigger than critical value, you reject null hypothesis. In this case, our answer is less than the critical value. So we don't reject it, null hypothesis. So we did not reject this. That means we are not taking this, meaning that the claim is incorrect. Then we're going to make our conclusion that it is insufficient evidence to support the claim that assistant professors earn more than $42,000 in a year in 1997. Now, this is how we do it for the traditional method. Now, we'll come back from the break from the holiday, I will show you another example when it is 2 tails test, and then we go to the p-value method. Now, any question in what I have solved? Any question?
Will you be posting this recording?
Oh, okay. You want me to post the recording? Sure.
Yes.
The one I posted last time, was that helpful?
Was it me that what?
I think I posted the recording for the last time we have a
Oh, yeah.
yeah, was that one helpful?
Oh, yes.
Okay, good. Okay, then I'll post it there. No problem. Any other
Okay.
question? Now, so some of you send me email. I'm gonna respond to all your email and then do more grading. Probably finish all the gradings before the holiday ends. So during the time we don't have the holiday, my schedule is so tight, so it slows me down in grading. But now that we have a holiday, I'm gonna have a long time to grade. Now, before we leave, let me show you what you need to do this week. This is the Thanksgiving week, so I'm not gonna bother you much. In my announcement, I have for week 4 for an assignment. I didn't give you any I have only one assignment, and it is not due until December 3. It is the project. The project. I want you to start now so that it will be less problem as we get close to the deadline. It's where can you find the project? You go to your models. Go to your models, and then you scroll down all the way to module 8. You can see where the project is located. It's in Word document. Start working on it. You can use Excel. When you finish your work in Excel, you can copy and paste it in that section of the project that need to be placed. No classwork today. Like I said, this is a holiday. I don't want to bother you. So no classwork, only this project. And remember, it is due in December 3. So you have more time. Okay? Now, back to the question option. So anybody else have any question to ask me?
I have a question.
Yeah.
Do we have to do it in Excel, or is it a suggestion?
If you want to, okay, let me show you what I mean by you're referring to the project, right?
Yeah.
Okay, give me 1 minute. Let me show you something. Let me open it. So it can be, see, this way is it. So see, so that like this part. Now the first one, list started data. So this one is say write down the number of minutes for each incident. Or say how many minutes do you sit down and work with dedicated concentration on your homework without interruption. So look at the time, check it for different time that you're working on homework and see how many minutes you spent. So I mean, it's up to you. You can use a random number to generate it. Okay. Let's say that you maybe I can explain it more. Now your question was, can we do it in Excel? Yes, you can do part of it in Excel, but this one, the step 1, you cannot do in Excel because you have to generate the number. Then you organize it. Consult a group frequency distribution. This one you can do in Excel if you like, but when you finish, paste the result here. Or if you cannot paste it here, you can write here that you can then submit 2 documents, one Excel and one this. You can then at this step you can type in here. As a matter of fact, I have a space here where you can put it. So if you can copy it in Excel and put it here, fine. But if you can't, you can just mention here that you can refer me to your Excel to see this part. Then this chart you do in Excel and paste it here. Or if you want to keep it in Excel, just tell me that the chart is in Excel. So whatever you did, if you want to do everything in Excel, except this part, the first step, if you want to do the rest of them in Excel, just when you come to that section, refirm it to where you have it in Excel. That means you have to number it properly in Excel. Okay? Did that answer your question?
Yeah.
Okay, good. Okay. Any other question before we leave?
Do we have class Wednesday?
Come on, who's saying this? Want me to come to school on Wednesday?
It's Thanksgiving break.
Oh, this sounds like Ania, right? Ania, is that you? Okay. No, I'm not, no, ma'am. I'm not coming to this campus on Wednesday. Any other question for me?
No.
Okay. Now enjoy your Thanksgiving. Remember, don't drink too much, okay? And I'll see you next week.
Have a happy Thanksgiving.
Have a good one.
You too, all of you. You too. Have a nice Thanksgiving. Let me put this out.